So, good day, grade 8 Mahati Science High School students. For our sixth module, okay, for our sixth lesson, and second to the last lesson for our topic in geometry for the fourth quarter, we have sector and segment area of circles. And you've seen the basics of the lesson. Now, let's go to the more advanced problems that we're going to try to solve for this given lesson. So, we have sector and segment areas of circles. So, let's say, for example, we have this problem. Okay, so Joaquin and Jake were fixing a conveyor belt. Given that it has three identical cogs, okay, identical meaning they have the same radius or they're all the same, they wanted to find the radius of each cog given that the length of the entire crown belt or the entire brown belt here or the entire conveyor belt is equal to 50 inches. Okay, so can we help them out for this problem? Okay, what we're going to do here, we need to identify the parts. Okay, so first let's imagine that this is a circle. Okay, so these cogs go over these conveyor belts. They're not drawn perfectly, but if you try to visualize it, okay, so they should be extended over here and also extending at this part. Okay, and these lines over here, so this line from this line, okay, so that's a radius. And from here to here, that's also a radius. And what did they say in this problem? All of the cogs are identical to each other. So therefore, the measurement of this part, okay, from here, that's gonna be r plus r, which is equal to 2r. And we're just gonna replicate that. Okay, that pattern is just gonna continue. Okay, so this is another radius, and this is another radius, so that's gonna be r plus r. This is also equal to 2r, or 2 radius, and also at this part and at this part. Okay, so this is also gonna be radius plus radius, and that's gonna be 2r as well. Okay, so now we have these parts. We're just missing these arc lengths. Okay, so we have three arc lengths here that are identical to each other as well. Okay, to get the measurement of the arc length, we need the formula for finding the measurement of an arc length. The formula for finding the measure of an arc length again is equal to the the radius times the angle itself. Okay, for this problem. Okay, and the angle here needs to be in radians. Okay, yeah, to get the arc length. Okay, so for this one, what we can see here, since all of the sides are identical to each other, they're all the same, so therefore this must be an equilateral triangle because all of the sides are the same, and therefore all of the angles are the same. So therefore this must be 60 degrees. So you have 60 degrees at this part. Yeah, so this angle over here, okay, let's use a different color. Let's use yellow. So this angle here, that's 60 degrees. This is 60 degrees as well. And this is 60 degrees. And what do we say about inscribed angles and subtended angles? If this is 60 degrees, the subtended angle over here should be 120 degrees. It should be twice the angle measurement of the inscribed angle over there. So therefore, your angle measurement is equal to 120 degrees. And what's 120 degrees in radians, in degree radians? So that should give us, if we're going to convert that, so that should give us pi all over 180 times 120. So that should give us 120 over 180 pi, or just simply 2/3 pi, or 2 pi all over 3. So therefore, this is going to be the value of our angle for this one. Okay, so therefore, to solve for the radius, we're going to need the length of the conveyor belt. Okay, so the length of the conveyor belt is going to be equal to 3 times the 2 radius that we have here, the 2r that we have here. So this is gonna be that part. Therefore, for this problem, we can get the value of r, or the value of the radius, by using the information that we have here. The length of the entire brown belt or the conveyor belt is equal to 50 inches. That's gonna be equal to 3 times 2 r, or twice the radius. Again, we have a radius over here and a radius over here, and that makes 2r. And we have 3 of these on the conveyor belt. So that's going to be 3 times 2r plus 3 times the area of the arc, or the length of the arc length. And the arc length is given by the formula, again, radius times the radians of the degrees. And the degree measurement here, since the angle here has been subtended, that's 120 degrees. And we have to transform that to radians. So that's going to be theta is equal to, this is the formula for transforming degrees into radians, pi all over 180 times 120. And in the end, it should give us 2/3 pi for this one. Okay, so this is gonna be theta times r. So therefore, 50 is going to be equal to 6r plus 3 times the value of the radians, which is 2/3 pi, okay, times r. And therefore, this is gonna give us 50 is equal to 6r plus, so that cancels out. This is just gonna be 2 pi r. And to solve for the value of r, we can just take the lowest term or factor the r outside of this expression over here. So that's just gonna give us r, okay, r times 6 plus 2 pi, okay, for this problem. And we can divide this by 6 plus 2 pi and 6 plus 2 pi. Therefore, the value of r is just going to be equal to 50 all over 6 plus 2 pi. Or if you want to take the lowest term, it could also be equal to 25 all over 3 plus pi. There you go. So therefore, the value of the radius is just equal to 25 all over 3 plus pi inches. Okay, and if we want to take the decimal value of that one, so that's going to be 25 all over 3 plus pi inches. So let's transform that into a decimal. So that's going to give us 25 all over 3 plus pi, and it should give us 4.07. So that's approximately equal to 4.07 inches for this problem. And that's how we solved it for this given problem.